Okay, last question for you. You should know how to do this. Given the periodic not on find the fundamental frequency W0 of Vs. So the fundamental frequency is going to be 2 pi divided by the period. And that's that's a good observation. That's the first thing you should notice about this formula, about this. It is an even graph. Remember what it means to be even and for it to be odd. Even means is reflected along the y-axis. Odd means is reflected along the x-axis. So an example of an odd formula, if this is 0, this would be an odd formula. If this is 0, yeah, it's fine if you're going to pass out. But we're almost done. You know, it's the last stretch. This is an example of an odd one because it's reflected along the x-axis. This is reflected along the y-axis. So it's an even function. You should be able to know how to tell even function. The more, you know, the more rigorous definition is that. And then odd is going to be, oh, sorry, no. And then odd is going to be f of x is equal to negative f of negative x. Someone correct me if I'm wrong. Am I going to be doing more tutorials? Maybe in the next semester. We'll see how it goes. Probably. Okay, so what is our period? What I like to do is I start on a rising edge like this, or whatever is like you feel would be the start of the function, and then you keep on going until you hit that same part. So as we can see here, from -2 to 6 is a is the sort of reoccurring formula. Now we take this and we move it forward so it matches the 0 line. Or you could just skip that and just figure out that it ends at 8. It repeats at 8. You do you. So the period here is going to be 8 seconds. T is equal to 8 seconds. And so our W0 is going to be 2 pi divided by 8. I don't know why I'm using a calculator for this, but it's 1/4 pi. I'm just going to try and rush through this a bit fast because I think people are starting to clock out. Okay. Find the fundamental frequency of Vs. Yeah, mode. Oh, sorry, this is the exact same question. Oopsie days. You see, even I'm starting to clock out. It's nearly 8:30. I woke up. I'm on 5 hours of sleep. Don't ask. So DC, yeah, mood. Oh, yes, this drawing application is called R-Note. You can search it out. Yeah, let me just pull it up for you. There you go. Oh, I used to use a very small tablet. Don't worry, we believe in you, man. We believe in you. Yeah. So DC component is just A0, right? So that's this is also on the end of your exam here, right here, A0. Oh yeah. You should know how to do this. Just Fourier. So f of t dt. Now, if you're given like a complex formula, It can be a little bit harder, but we're not given a complex formula. You can just do the definition of an integral, right? The area underneath the curve. Whee! I think I actually don't know. Yeah, it should be. So so you just take the area here, and the area here is going to be 8. Now 1 over t is going to be 1 over 8, so this comes out to 1 volt. All right, so there's DC, right? The area is 8. So this is going to be 1 over 8. 8 is equal 1. Next part. What's the next part? Here you go. Find coefficients for the cosine components of Fourier series. Again, you should be able to figure this one out. This is just plugging in. We also know it's even, so we can use the even shortcut. So this is going to be f of t cosine of nw0t dt. Is it always equal to 1 volt? No. It's equal to 1 volt here. What is f of t? This is f of t. It's this line here that goes up and down. And so this is just Fourier. Because there's a hard jump here, we split it up into multiple equations, right? But so in this case, we would do 4 over t, 0 through 2, 6 cosine of n pi over 4. Sorry, I'm a little rushing this because this is just, plus, bracket there, 2 to 4, e. Move that along. This is going to be negative 3 cosine of n pi over 4t dt. He just barely fit. Perfect. You do the math. This is all just algebra. I'm sorry. I really don't want to just go through all the algebra again. You should be able to do that. Your final thing will be an is equal to 16 over n pi sine of n pi over 2. Go review your 312 notes if you can't do that. And then it asks for n, evaluate for n, 1, 2, 3, 4, 5, 6. You should be able to do that. You just plug in n for each one of them. But do make sure, because if you're just plugging it in and you're using sine, if you have been using, can you spam questions for a study hall tomorrow? I don't know. Are you asking me or are you asking complex? I assume you're asking complex, but spam oh yeah, you can ask me questions about study hall tomorrow. Don't worry. Just remember, if you're using sine on your calculator, if you've been working up to this point, it's probably going to be in what do you call degrees. You should be using radians now. You should be using radians. So you need to switch your calculator to radians at this point. Anyway, do the math. Very simple. I'm going to skip that. I'll add my work there in post. Like my background work in post. D, find the coefficients for a sine of the Fourier series of Bn. This is an even function, so Bn is 0. And then finally, approximate Vt by its DC component using the first sine and the first cosine term. Calculate the VO of the responding circuit. Do we have room for this? I'm going to move this down a bit. So if so the first cosine term is 0, right? We just need the first cosine term and its DC component. So it's going to be 1 plus, and if you do the math, it's going to be 16 over pi cosine of pi over 4t. So you'll notice we have the DC part and we have the AC part. So we need to solve this equation actually twice. This is superposition, if you remember. I know we're going back to superposition. Deal with it. So we're going to calculate this part and then this part separately. So let's look at the first part, the DC component. So this is a single volt passing through. We have an inductor which turns into an open circuit, or sorry, a short circuit, and then a resistor here, 5 ohms. So our VO of T is just going to be 1/5 of an amp. And then we do part 2. This is superposition, sorry. Part 2. We have our inductor, we have our resistor. This is 16 over pi with the phase of 0 because it's cosine, right? Now, if you happen to have a sine part, what you would have to do is you would just have to add it up in phasor form, right? So say if you have 16 over pi cosine of this. How do I say this? Okay, let me take this. Suppose if you had a sine part. What you could do is, so for example, 8 over pi sine of pi over 4t. You convert this into phasor form. So it's going to be 16 over pi with a phasor of 0 plus 8 over pi with a phasor of -90. Now you can add them together. And by the way, remember, if you've been using degrees or if you've been using radians, you have to switch back to degrees or you'll get it wrong. Watch your degrees in radians. Anyway, the omega for this part is just going to be pi over 4. So this is going to be JWL, which is W is pi over 4. So therefore, JWL is going to be equal to 5 pi over 4. J. And this is still 5 ohms. VO of T is going to be 4 with a phasor of -38 degrees. Now you just add them together. This is VO1, this is VO2. So VO is going to be equal VO1 plus VO2, which is going to be 4.16 with a phasor of -36. And that's the end. Holy God. 2 hours, 40 minutes. Actually, 2 hours, 30 minutes. Are there any questions? Can I screenshot it? Yeah, definitely. I will be posting the PDF very quickly. Anyways, I would love to stick around, but I am actually running late for something else, so I do have to go. But thank you all for attending. Good luck on your exam for everything. And you feel free to like DM me or text me anything. What am I running late for? Don't worry about it. All right. Have a good one, guys. I need to stop recording.